Welcome to RaWMachines, your journey to explore the world's most impressive industrial processes. Amidst the massive scale of global commerce, there is a hero quietly carrying billions of tons of goods every year, the wooden pallet. How can humans transform rough tree trunks into millions of consistent, durable, and sturdy pallets? Join me as we delve into modern factories to better understand the process of creating this essential material. For thousands of years, humanity has wrestled with one question: how can we move goods easier, faster, and safer? 1. The early period, manpower as the main engine. In ancient civilizations like Mesopotamia and Egypt, people had to carry, pull, or place goods on wooden sleds. Wooden crates, bamboo baskets, and clay jars were the first containers used to protect products. However, these tools were heavy, cumbersome, and completely dependent on human or animal power. Long-distance transport, therefore, consumed immense energy. 2. The Middle Ages. Oldest. When the cylinder changed the world, moving into the Middle Ages in Europe, maritime trade flourished. On these ships, a seemingly small but revolutionary invention emerged: the wooden cylindrical barrel. Thanks to this design, goods could be rolled instead of dragged, stacked easily without fear of breakage, and optimize space in the ship's hold better. However, as the scale of trade grew, surpassing human capacity, the barrel began to show its limits. It was no longer flexible enough for the emerging industrial production line. 3. The era of industrialization, waiting for the lift. At the end of the 18th century, the Industrial Revolution erupted. Simultaneously, the demand for movement within factories, ports, and warehouses grew exponentially. People began using square wooden boxes instead of cylindrical barrels. But even though wooden boxes were stronger and more durable, they still relied on human strength. At the first ports in England and America, goods were loaded and unloaded manually. It took dozens of men and hours to arrange just one ocean container. The world had the steam engine, but it still lacked the engine for lifting cargo. 4. The forklift revolution and the birth of the pallet. And then, in the 1920s, the forklift was invented in warehouses across the United States. This machine could lift hundreds of kilograms with just a mechanical lever, but it needed a flat base for its forks to slide into. That was the moment the wooden pallet was born. Together with the forklift, the pallet created a duo that changed the entire global supply chain. Loading efficiency tripled or quadrupled, labor costs plummeted, and cargo damage became nearly non-existent. Five, the modern era, the invisible foundation of globalization. Today, the pallet is no longer a temporary solution. It has become the common language of logistics. It is estimated that over 5 billion wooden pallets are currently used globally, transporting over 80% of the world's cargo. They exist in every sector: food, pharmaceuticals, electronics, construction, and agriculture. Interestingly, despite technological advancements, the dominant material for pallets remains wood. This is because only wood is light enough, durable enough, and environmentally friendly enough to serve billions of shipments annually. Now, join me to explore the fascinating process of how these essential pallets are made. Every journey has a starting point, and for wooden pallets, that starting point is the raw material yard. From above, the area looks like an endless sea of wood. Hundreds, perhaps thousands of round logs lie parallel on the ground, stretching toward the horizon. Each trunk is a story, some cut from northern pine forests, others sourced from European oak groves. They differ in species, size, and moisture content, but all await the same destiny: to become material for a modern production line. Now, the log crane begins its work. With colossal hydraulic grapples, it gently lifts, rotates, and places each log onto the feed conveyor. Every turn and every set down is calculated, as if the entire yard is performing a meticulously programmed mechanical ballet. After leaving the storage yard, the log's journey truly begins. It first goes through the debarking stage. While it sounds simple, this is a crucial step that determines the precision, the durability of the saw blades, and the quality of every board produced afterward. The machine looks like a round tunnel, inside which dozens of steel rollers and rotating teeth are continuously mounted. As the log passes through, the rotating shafts press tightly and spin in opposite directions, stripping off the outer bark in just a few seconds. In modern mills, the system also incorporates high-pressure water jets to clean impurities, washing away dirt, grit, and moss. You might be wondering, where does the bark go after it's stripped? Typically, this bark is collected and processed right at the mill. The larger pieces are kept to be used as mulch, while the finer parts are compressed into biomass pellets. The energy generated from these pellets is capable of supplying the necessary heat to run the mill's drying and heating systems. This helps the production facility become partially energy self-sufficient, reducing reliance on fossil fuels and significantly cutting carbon emissions. Additionally, they are also used as soil conditioner or landscape cover, providing nutrients and retaining moisture for agricultural land. This is the turning point for the 21st century wood industry, not only producing quickly and precisely, but also being greener, cleaner, and more sustainable. After being debarked, the wood enters a phase of comprehensive health check, where digital scanning technology takes on the role of the human eye. On the central conveyor belt, round logs pass through a system of 3D laser scanners combined with X-ray sensors. Millions of light points scan across the trunk, creating a complete three-dimensional map of its internal structure. As a result, every grain, every knot, and even tiny cracks hidden deep within the core are clearly displayed on the computer screen. If this decision previously relied entirely on the sawyer's experience, today, AI acts as a tireless, flawless master analyst, always providing the precise choice. This doesn't just boost productivity, it radically transforms how the lumber industry operates, from handicraft to data science. The next step is where that data is brought to life, opening up the main sawing stage, the heart of the entire process. The air inside the mill is always thick with humidity and the smell of wood resin. Steel rollers continuously spin, pushing each log toward the sharp saw blades. Before the blade touches the wood, the laser scanning and X-ray sensor system check the log once more, confirming the data with extreme precision. Engineers monitor every millimeter of movement via screens. Data displays constantly: sawing speed, clamping force, vibration, and blade temperature, all automatically adjusted in real time. And then, the familiar sound rings out, and the saw blade begins slicing through the trunk. In just a single breath, the round log is transformed into square wood blocks, known as cants, the foundation for every product that follows. This stage is not merely about breaking down the wood. It is the step that determines the entire economic value of the tree. The system always selects the plan that yields the highest efficiency, minimizing sawdust waste. Looking at the cants just cut, we see the beautiful contrast between nature and technology. From the random wild shape of the forest tree, we now have clean, uniform, square blocks of wood. After the first square blocks, cants, are created at the main sawing section, the refinement journey begins. The goal of the secondary cutting stage is no longer power, but precision and material efficiency. From these large cants, the mill separates dozens of smaller boards, each optimized in size, thickness, and grain direction for specific pallet components. Sensors record every small flaw revealed after the first cut, dead knots, cracks, or deviation in the grain. All this data is instantly processed by software to calculate the refined cutting path, to maximize the usable good wood, while eliminating defects that could compromise the product's durability. From the control center, commands are transmitted to the multi-saw and the optimizer saw line. Rows of blades move rhythmically, cutting, separating, rotating, and pushing. The boards slide continuously at high speeds, yet every cut is accurate down to the millimeter. In this space, the sound is no longer a grating shriek, but the steady rhythm of productivity, the sound of wood cutting, compressed air, and servo motors blending like a mechanical symphony. In another corner, boards that have been processed are neatly stacked by robotic arms according to thickness and length. Standardized wood proceeds to the edging section, while rejected pieces are sent to the recycling area, where they are chipped into sawdust, continuing their journey into the production line for particle board or energy pellets. As the final board leaves the conveyor, the difference is clear. The wood is no longer a rough blank, but a standardized industrial material with definite shape and value. Every board is a standardized unit, ready for the next step. After passing through the initial saw blades, the boards now have a relatively complete shape. However, their edges still bear natural boundaries, curved, rough, and uneven. To turn them into industry-standard products, a final refinement step is needed: edging. On the high-speed conveyor, each board slides through a series of guide rollers. On either side, continuously rotating saw blades shave off the unusable edge material, restoring the wood to a precise shape with flat, sharp, parallel sides. In modern mills, this stage is entirely automated. Optical sensor systems scan each board, accurately reading its actual shape, and then instantly adjust the distance between the two saw blades to achieve optimal precision. After being perfectly edged, each board continues its journey to the end trimming section. Here, a series of high-speed circular saws are aligned horizontally. Laser sensors scan each board, measure its length, and then issue the cutting command at the designated position. With one quick, decisive slice, both ends of the board are cut absolutely square. From this point, all boards achieve the standard industrial size, typically ranging from 1,000 to 1,200 millimeters, making them ready for pallet assembly in the next stage. Automated grading and sorting. The end trim boards are then sent through an automated image scanning and sorting system. High-resolution cameras record every surface, identifying color, grain direction, knots, cracks, and even minor burns from sawing friction. AI software analyzes the images instantly, scoring the quality based on multiple criteria: flatness, brightness, uniformity, and structural defects. Based on this analysis, an automated system using compressed air and paddles sorts each board into the appropriate group. Grade A. Even grain, few defects, used for export pallets and high load-bearing structures. Grade B, minor knots or slight curvature, suitable for domestic and industrial pallets. Grade C, inconsistent surface or minor cracks, redirected to secondary products, recycling, or composite pellets. As the final standardized boards are stacked, we see a neat warehouse where hundreds of thousands of boards are uniform, each carrying its own identification code for traceability of origin, size, and quality. This is the epitome of modern manufacturing, not just creating products, but managing their complete data history from the forest to the factory floor. When the last board leaves the sorting station, its journey doesn't end. It's just beginning a new chapter. To prepare for the drying stage, every board needs to be stacked precisely, with perfect ventilation and balance. This is where the automatic stacking system begins its operation. Between each layer of boards, the system inserts thin wood strips, called stickers. They are evenly spaced to create gaps for air to circulate. This ensures that when the stacks are placed in the kiln, the heat can distribute uniformly, helping the wood dry consistently from the inside out. Beneath the machine, wood blocks gradually form, tall, square, and perfectly layered, with each bundle weighing up to several tons. All are coded, tagged electronically, and saved in the management system for tracking throughout the subsequent heat treatment process. This stacking system doesn't just increase productivity, it guarantees consistency for the entire production line. At this large scale, a robot can handle thousands of boards per hour, operating continuously 24/7 without rest. As a result, the entire process becomes seamless. Boards cut in the sawing area are immediately stacked and prepared for the kiln, preventing backlog and damage. Now, the boards are ready for a new challenge: heat and time. In the world of modern manufacturing, this is considered the most crucial refinement stage. Only proper drying ensures long-term durability and stability. Inside the kiln, the temperature fluctuates from 60 degrees to 90 degrees, while the relative humidity is gradually reduced from 50% down to just 12% to 20%, the ideal level for pallet production. Moisture sensors embedded deep within the wood constantly transmit signals to the control center. When a variance is detected, the system automatically adjusts fan speed, steam exhaust volume, and airflow direction, ensuring every board dries uniformly from the inside out. When the process is complete, the steel doors open and the stacks of dry wood are revealed in a warm, hazy mist. The surface of the boards is now brighter, lighter, and sounds crisply dry when tapped. This is the perfect state to continue the next phase of fabrication. But to become a pallet, the foundation supporting billions of tons of cargo every year, the wood needs to be precisely machined to create structural components suited for global industrial design. The conveyor belt thus carries them to the component processing plant, where each board is reshaped and begins to assume its specific role in the structure. On the first line, crosscut saws and rip saws operate continuously, cutting the boards into deck boards, the horizontal face planks, and stringers, the vertical load-bearing beams that run the length of the pallet. Each component is cut to international standard sizes, typically ranging from 1,000 xpd to 1,200 millimeters, with a tolerance of just +1 meter. Laser sensors constantly measure and adjust the cutting blades, ensuring every cut is equally sharp, straight, and consistent. After being cut, the stringers are moved to the notching machine, a specialized piece of equipment that creates the unique signature of the modern pallet. High-speed circular cutters bite deep into the middle sections of the beam, cutting out perfectly uniform U or L-shaped notches. These notches are precisely what allow the forklift to access the pallet from 4 directions, facilitating flexible movement in warehouses or containers, and establishing it as the global standard for modern logistics. Next, the wood components are transferred to the planer and sander, where surfaces are flattened and edges are softly rounded off, ensuring there are no sharp splinters that could scratch or damage cargo. Automatic steel brushes sweep across the entire surface, lightly polishing the outer layer, creating a smooth feel while preserving the natural wood grain. Now, all the components are ready to enter their final shaping moment, where everything merges to become a single structure, the pallet. In the vast assembly hall, dozens of workers and assembly robots operate in harmony. The steps unfold sequentially, picking up the deck boards, placing them on the stringers, aligning the position, and then high-speed coiled nail guns immediately fasten each connection point. All this happens within seconds, fast, precise, with no deviation, even by a millimeter. Coordinating smoothly with molded conveyors for easy assembly. One person places the stringers, another attaches the deck boards, and a third secures the base. Each movement is swift and decisive. This is the rhythm of experience and professional skill, something only time can cultivate. A standard pallet can be assembled from 9 stringers and 10 to now 12 deck boards and bottom boards. All are secured with hundreds of galvanized steel coils and sharp electric screws, enduring compression loads of up to several tons without failure. At the end of the line, the first finished pallets emerge. The light reflects off the pale wood. The nail marks are perfectly aligned, and the surface is flat and sturdy, like a block of steel. From a distance, seeing hundreds of pallets slide off the conveyor, stacked high, one can feel the power of modern industry, where every movement serves a clear purpose. Now we reach the final stage, packaging and distribution. From the inspection station, the finished pallets are automatically conveyed to the staging area. They are stacked in an interlocking pattern to form uniform, stable blocks, optimized for transport. Each block typically consists of 10 to 20 pallets, which are tightly compressed and bound using double steel banding or high-strength plastic strapping, keeping the entire bundle secure throughout its long journey. Forklifts line up and move into the outbound area. To the sound of warning beeps, each pallet unit is lifted and smoothly slides into the waiting container or truck bed. From here, the pallets will follow the goods around the world, across oceans, through deserts, to warehouses, ports, construction sites, and factories, silently supporting every economy. No matter where they are, they maintain their original role, unassuming, durable, and irreplaceable. Each wooden pallet is a small cell in the global transportation system. When they move, the world operates. From an anonymous trunk deep in the forest, through dozens of meticulous stages, the wood has completed a long journey. The initial saw blades shaped it, the heat in the drying kiln purified it, and the robotic arms transformed it into the foundation of the modern world of goods. Throughout this journey, the wood is changed, from raw to refined, from natural to industrial, from material to foundation. But one thing has not changed: the value of the people behind the production line. The engineers, workers, and programmers each contributes to the rhythm of the entire world's operation. Without them, there would be no precision, no standards, and no global commerce as we know it today. When a pallet is set down, lifted, and then leaves the line, we don't just see a wooden product. We see the very breath of humanity, of engineering, of the respect given to the material that sustains the economy. It is proof that even the most simple object, when crafted with intellect and dedication, can keep the world moving. The wooden pallet, small but keeps the world moving. That is the final message this video wants to convey. A tribute to the forests that nourish the raw material, to the hands of the artisans who preserve tradition, and to the technology that has helped humanity elevate the lumber trade to new heights. Thank you for joining RaWMachines on this journey. If you also love videos like this, please hit the like button, share, and subscribe to the channel so you don't miss any of our exciting upcoming stories. This is RaWMachines, and we'll see you next time.